Namaste to all. Hope all of you might have watched my previous video on solutions. In this video, I'll be discussing some in-text and text-back exercises based on Henry's law. The first question in your in-text based on Henry's law constant is H2S is a toxic gas with rotten egg-like smell and is used for qualitative analysis. If the solubility of H2S in water at STP is 0.195 moles per kg, calculate Henry's law constant. A very easy question. The KH value you are asked to calculate, the solubility is given in this question. So let us go to the answer part. We have learned what is Henry's law. According to Henry's law constant into mole fraction is equal to partial pressure of the gas, or KH is equal to the partial pressure of the gas divided by the mole fraction. Here, the temperature and pressure, it is given at STP. The solubility of H2S in water at STP's value is given. So, pressure here is 1 bar. And solubility is given in the question. It is 0.195 moles per kg. So, these are the things given. Moles of H2S is obviously 0.195, which is very clear. Moles of water. To calculate the moles of water, it is in 1 kg. That is 0.195 moles in 1 kg. That is 1000 grams. So, mass by molar mass. So, the mass is 1000 divided by molar mass of water is 18, which you get it as 55.5. Therefore, to calculate the mole fraction of H2S, number of moles of H2S is 0.195 divided by the total number of moles is 0.195 plus the moles of water is 55.5, which is 0.0035 or 3.5 into 10 raised to minus 3. So, the mole fraction of H2S is 0.0035. Now, to calculate KH, according to Henry's law, we have discussed earlier, KH is equal to the partial pressure of the gas divided by the mole fraction. The pressure here is 1 bar, which is already given at STP. So, it is 1 bar divided by 3.5 into 10 raised to minus 3 or 0.0035. The answer is 285.6 bar. Hope this is clear to you. Next, we'll go to the second question. The second question is Henry's law constant of carbon dioxide in water is 1.67 into 10 raised to 8 Pascal at 298 Kelvin. Calculate the quantity of carbon dioxide in 500 ml of soda water when packed under 2.5 atmosphere carbon dioxide pressure at 298 Kelvin. So here the question asked is to calculate the amount of carbon dioxide in 500 ml and not in 1000 ml. So, you are asked to calculate the amount. Henry's law constant is given here. Pressure is also given. So, it is simply direct application of Henry's law constant. So, in the answer section, pressure of carbon dioxide is 2.5 atmosphere. But the Henry's law constant is given in Pascal, PA. So, we have to convert atmosphere into Pascal by multiplying it into 101325. You get it as 253312.5 Pascal. So, you have made the unit same. According to Henry's law, we all know the mole fraction of carbon dioxide is equal to the partial pressure by Henry's law constant. Substituting the values, pressure of carbon dioxide, earlier we got it as 253312.5 Pascal divided by the Henry's law constant is given in the question 1.67 into 10 raised to 8. You get it as 1.52 into 10 raised to minus 3. Please do the calculations in your notebook and check whether the answer is correct or not. Now, in order to calculate the amount of carbon dioxide, we have to calculate the mole fraction of carbon dioxide. Mole fraction of carbon dioxide is equal to number of moles of carbon dioxide divided by total number of moles. Total number of moles is number of moles of carbon dioxide plus number of moles of water. the amount of carbon dioxide, number of moles of carbon dioxide is very little. The amount is very little, so that can be ignored. So you get it as number of moles of carbon dioxide divided by number of moles of water only, which is 55.5. Number of moles of carbon dioxide, you have to calculate the number of moles first. The mole fraction into, you got the mole fraction earlier, 1.52 into 10 raised to minus 3 into the number of moles of water is 55.5. So number of moles of carbon dioxide is 0.0844 moles per liter. So this is in 1000 ml of the solution. But the question asked is in 500 ml. So moles of carbon dioxide present in 500 ml would be 0.0844 divided by 2. Once again, the number of moles of carbon dioxide that you got 0.0844 is in 1 liter. But here that is 1000 ml. So here it is asked in 500 ml. So we have to divide by 2. You get 0.0422. That is number of moles of carbon dioxide in 500 ml is 0.0422 mole. Now the amount, when you get the number of moles, number of moles is equal to mass by molar mass. You know the formula. So mass is equal to number of moles into molar mass. Once again repeating it, number of moles is equal to the mass by molar mass. So mass or amount is equal to number of moles into molar mass. So amount of carbon dioxide present in 500 ml is 0.0422, which is the moles of carbon dioxide into the molar mass of carbon dioxide. Carbon 12, oxygen 16 into 2 becomes 44, and the answer is 1.86 grams. Hope this answer is clear to you. And the text end or chapter end question. There's only one question based on Henry's law in the end of the chapter. The third question is also very easy. The partial pressure of ethane over saturated solution containing 6.56 into 10 raised to minus 2 gram of ethane is 1 bar. If the solution contains 5.5 into 10 raised to minus 2 gram of ethane, then what will be the partial pressure of the gas? So there are two cases here. In the first case, you have to calculate the Henry's law constant. And in the second case, the amount of ethane is changing. So in the second case, you are asked to calculate the partial pressure of the gas. You will get KH value from the first case. Using the KH value, you will find the partial pressure of the gas. So we'll go to the answer. Here also it's according to Henry's law. Mole fraction, there earlier it was taken mole fraction. Mole fraction or solubility, yes, solubility is directly taken in grams. So M is equal to the Henry's law constant into the partial pressure, or Henry's law constant is equal to the mass divided by partial pressure. The mass given is, in the first case, is 6.56 into 10 raised to minus 2. And the pressure of that is 1 bar. So divided by 1 bar is 6.56 into 10 raised to minus 2 grams per bar, or grams per bar. The second case you are asked to calculate the partial pressure of the gas. Second case, partial pressure is equal to the mass divided by Henry's law constant. We have earlier calculated Henry's law constant. So the mass is changing here, is 5 into 10 raised to minus 2 divided by, we have calculated KH value, it is 6.56 into 10 raised to minus 2. You get the answer as 76.21 bar. Thank you for watching this video.